Hey everyone, in today's video we're going to have a look at metals for their A-level written exam for AQA. So typically this is going to be in paper 1, which is more about materials, properties, manufacturing processes, how and why you're using the materials you're going to use, those sorts of things. So really when it comes to metals and just materials in general, there's a few things you need to be able to talk about. So basically be able to, with specifically to metals, is understanding the difference between ferrous, non-ferrous and alloy metals, being able to give examples of each one of those groups, and then along with that as well, being able to give examples of applications, so uses for those metals as well. So before we get into the actual metal side of it, this little bit here is more of the material property side of thing. The same goes for all the different materials that you have. And the reason why, if you there is an exam question and it asks you what material it's made from, and you say a metal, or you just say metal or plastic or timber, the reason you get no mark is because it's a very, very generic term. You need to make sure you understand the right material for that specific job. So within metals, some of the properties can be vastly different. So you take, for example, like a fizzy drink can, like Diet Coke, um, typically made out of like aluminium, okay, for a number of different reasons. Absolutely fine. If you made it out of lead, you're going to end up poisoning and killing a load of people. Okay, the same reason why aeroplanes, again, aluminium, you don't make it out of steel because it's too heavy. Okay, it's not going to get off the ground. So it's understanding that within those subcategories of materials, you need to understand why something's more suitable than another material. Now, the reason for that is to do with the properties. So, typically, what you would do if you're in the manufacturing or the designing industry is you'd design whatever you're going to design and you'd think about what its use is going to be. So, you'd think, what properties does this material need to be able to work properly? So, if something is working, going to be used outside, um, it's going to need different properties than something that's going to be used inside, or if something's going to be exposed to a great amount of heat and tension, then it's going to have a very, very different properties to something that's just going to be a display piece. So it's understanding that just because it's grouped as a metal, you need to be more specific and say why each material is more suitable than another one. Now, there may well be a time when there are questions when there are multiple possible right answers, and in those instances, in the mark scheme for the questions, there are normally more than one right answer, as long as you can justify and explain it. So, with that, properties are typically broken down into two groups. You've got mechanical and you've got physical. So, mechanical properties are to do with external forces that will happen on the material. And then physical properties are to do with the actual makeup and the structure of the material itself. Now, I'll show you some examples in the next couple of slides to hopefully make you understand that a little bit more. But just remember, mechanical is to do with external forces being applied to the property, to the material or the product, and then physical properties to do with the actual internals of the material itself. Just be aware that the most common thing is people mix those two up. So there are questions where it asks you to name physical and mechanical properties, and people can write a perfect answer, but because they got the two mixed up, they end up with no marks. So mechanical properties, we say these are the ones that are external forces. So think like compressive strength. So if you're wondering about something that might need compressive strength, simply put, something like a chair or a workbench, where the legs are being under compressive strength because of the weight of the tabletop, the weight of people sitting on things, so it needs to have good compressive strength. Tensile strength is to be able to be pulled apart. Bending strength, as explained, quite self-explanatory really, is to be able to withstand bending without breaking. Shear strength is to do with sliding forces down a parallel plane. So if you imagine the easy way to imagine that is like a pair of scissors, so that would be shear strength. Torsional strength is twisting. Then you got the common ones like hardness, toughness, plasticity, ductility, malleability, and elasticity. So those hardness is like ability to stand wear and tear. So that's abrasive wear and indentation. Toughness is the sudden impact. Plasticity is how well something can be deformed into a new shape without breaking. Ductility is being able to stretch without cracking. Malleability is be able to withstand, be able to change shape while being like compressed. So that might be like hitting it with a hammer. So it used to be some people where they make like custom bike parts and those sorts of things. They will work with malleable material so they can hit it into shape over a former. Then elasticity is the ability to be deformed and then go back to its original shape again. Now, these properties don't necessarily just apply to metals. All these sort of properties may well apply to timbers, polymers, papers, and cards. Those are sort of things as well. And these are sort of the generic terms. So these are the terms where if someone's asking you why a material is suitable, these are the kind of reasons you would give. Because typically at A level, you're probably looking at A, B, C, D kind of question. So A may be name a suitable material for this product, and it could be anything. It could be a kitchen sink, it could be a garden bench, it could be a children's bike, it could be garden furniture, it could be anything like that. So part one will be name a suitable material, which is normally like a 1 or 2 mark question, relatively simple. Next question tends to be a longer mark question, maybe like a 6 or an 8 mark question, which say explain why that material you selected is suitable, and that's where you will bring up the properties. Not it might be mechanical, it might be physical. It may ask you to specify explicitly whether it's mechanical or physical, but then you would explain these properties are why this material is more suitable. And then part C and part D might well be explain how it could be manufactured, those sorts of things. That's sort of giving you the context of the question that you might end up getting. So physical properties, so these are to do with the actual internals of the material. So things like is it a good electrical conductor, insulator? Can it conduct heat, or does it insulate heat? How does it react with light? Does it prevent light from passing through? Does it let light go through, but it diffuses, so i.e. it makes it like blurry, like with your bathroom windows, so you don't like flashing people when you get out of the shower? Does it let light out completely anyway? Density is just the sheer mass of the material. Fusibility is how well can it be converted from a solid to a liquid, so you can melt it down to use it for something else. Magnetism, so does it have magnetic properties? No, that it's only ions and steels that relates to, because it's to do with ferrous metals. So all ferrous or most ferrous metals are magnetic. Then corrosion and degradation resistance, and that could be to do with oxidization, so rust reacting with the air. That could do with moisture. That could be to do with chemical resistance. That could be so a range of different things. So corrosion degradation resistance is a bit more of a generic term. So you might say, for example, it is chemical resistant, so you can apply bleach to it and clean it without it breaking down, or it's moisture resistant, so it won't rust while you're washing something in the sink, that sort of thing. So mechanical and physical properties. Now there are other kinds of ones you might talk about as well, but typically, as I said, these are the ones where when you've got to explain why a material is suitable for a given product, these are the reasons you would have to give. So you typically get a mark for bringing up the right property, and then another mark for explaining why does that matter for the product that you've chosen. So before we talked about like furniture, so you say a chair, well the legs are made out of um, aluminium or stainless steel because they need to be uh, relatively good compressive strength, because otherwise the chair will collapse. So that little bit was to do like the more general side of materials. So now we'll look specifically at the metal side of things. So to begin with, we'll start from the very, very beginning of where metals actually come from. So metals don't actually appear as like their normal form in the ground naturally. Okay, you don't just find copper, aluminium, lead, tin, zinc, like these sorts of things. You don't just find them in the ground as they are. They need to be extracted from what's called an ore. So you find the ore, and they need to be extracted. So typically are done with things like electrolysis or carbon reduction. So it's unlikely that you're going to be asked to say, like, it would be very mean if an exam question was to say, please tell me what ore iron is extracted from. But it's good to make sure you understand they come from ores naturally, and they are extracted from that. The only one I can always remember off the top of my head, no problem, is bauxite for aluminium, because it's just always stuck in my head. But it's just good to understand where they come from. The only exception to the rule for this is gold, as gold is a pure metal that you find exactly as it is in nature. So when you dig it up, you find it as gold nuggets. So types of metals. So really, you've got two main types of metals, and you get like a little subcategory. So ferrous metals are your metals that contain iron. So that would be Fe in the periodic table. So typically that is your ions, and then that is your steels. And I'll explain why it's those steels in the next few slides. But essentially, you've got iron, and then you add carbon to it in some percentage, and then you end up with the different kinds of steels that go along with it. Then your non-ferrous metals are the ones that do not contain iron. Now, those are the two main groups. Then along with that, you've got alloys. Now, alloys are a mixture of two or more metals to create better, stronger, different property metals. Now, it's important to say, so where you can lose marks sometimes, if you just say it's a mixture of two metals, it's got to be it's two or more, because there are some alloys that have got a mixture of three or four metals in there as well. So just make sure you don't mix, or you don't like risk losing marks by just saying two metals. Make sure it's at least two or more. So metal uses. So as we talked about before, um, to understand why it's used for something, first of all, the properties have to come first. So you understand, here's the thing, whatever this may be, that needs to work. Okay, these are the properties. This is going to withstand a huge amount of heat. This is going to withstand compressive strength. This has got to withstand like surviving outside. So you understand these are the properties I need. Okay, so this means it can be used for these things. Okay, so that's why it's so important to make sure you understand the properties of these materials. So things like copper, we know it is very, very good thermal and electrical conductor, hence why it's used so much in things like piping and wiring. Now, it's been used a little bit less in some electrical wiring now because gold's been used a little bit more because gold is a very, very good conductor of electricity. And it turns out at the moment, gold, there's actually more gold than people thought there was. It's not quite as rare of a material, which is why I think like HDMI cables, you're finding a lot more gold plated ones. It's not so much used in cooking pots anymore. It used to be quite a lot, but it's just sort of kind of been used. There's other materials that have been used a bit more instead. And it is unreactive with air and water, so basically means if you left it out, it won't rust over time. So aluminium, so typically used like aircraft frames. It's used in some wires, things like bicycle frames, drinks cans, those sorts of things. It's strong, lightweight, unreactive. The key one here being unreactive, so it doesn't react to anything. It's not going to contaminate. So if things are reactive, if you were to then say pour a drink into it or pour a chemical into it and it reacts, that basically means it's going to contaminate whatever you're putting in. Now in there, I've written strong and lightweight. Avoid in an exam question, if the question ever asks you, why is this material suitable? Avoid just saying it's strong, because again, that's a very, very generic term. If you're going to talk about the strength and the weight of it, typically the correct term really to use would be it has a good strength to weight ratio. It basically means for the weight this material is, it is very, very strong. And aluminium's got a fantastic strength to weight ratio, which is why it's used in things like aircrafts, because it's very, very strong. But compared to other metals that got the same sort of strength, it's a lot lighter. So iron, typically used in things like car bodies and structural steel, because you can form. It's very iron on its own is not great, but you can make very, very good alloys from it because you can get all the different kinds of steel from it, and it's malleable, which means it's really, really easy to work with. So lead, again, properties very, very malleable. Used like roof flashings, strong batteries, those sorts of things. It says solder there. It's not so much used for solder anymore, mainly because lead is very, very poisonous. And there was years and years ago, before health and safety was really a thing, and there's a lot of electrical engineers were suddenly getting very, very ill in like their early 30s, early 40s, because they were inhaling this smoke that had lead in it. And it turns out it's incredibly poisonous, so which is why lead's not used as much. Zinc is mainly used as like a protective coating for something else. So typically galvanizing, so it'll let you alloy it with other things and it'll add a protective coating that allows it to go outside and not degrade over time. Tin, very good because it's just unreactive with air and water, so it won't rust again. So again, you're coating on things. You can get frost-free windshields that stop your windshield from actually like frosting over in the winter. And then silver, so malleable, so easy to work with, ductile and non-reactive, and typically normally just used in jewellery and those sorts of things because it's pretty. And again, if you're going to say that, you would say it's aesthetically pleasing. So just make sure when you're talking about the properties of things, you're talking in terms of the proper A-level technical language that's expected of you. So rather than saying because it's pretty or it's shiny, it will be aesthetically pleasing, which is why it's used so much in jewellery. So ferrous metals. So as we said, these are the ones that are essentially iron and then something else. Because on its own, iron is relatively useless because it's so soft. So you need to do something. It's very, very malleable. So you need to do something to it to make it more useful. And what you do basically is you add some carbon to it. Okay. Now the amount of carbon you add to it varies and you get different results from it. And typically, and it's a very ingenious name here, you got low carbon steel, medium carbon steel, and high carbon steel. So what you do, you're never going to be asked, or at least you shouldn't be asked, because again, this would be quite mean if they did. What percentage of carbon do you add to iron to get low carbon steel? That would be a very mean question if you were able to get that, and I don't think it's likely. But being able to understand that to get different kinds of steel, you have your iron, and then you add some carbon to it, and then you end up with a steel. When you're talking about materials in exam questions as well, there's a few. There seems to be a lot of rules when you talk about materials. If you ever mention iron, don't just say iron. Typically, you'd go with cast iron. So because there may well be a question where asks you to name a ferrous metal. So, for example, it may be what is a ferrous metal, and it's a metal that contains iron. Give an example of a ferrous metal. You wouldn't be allowed to just say iron. It sometimes specifically says in the mark scheme, don't accept iron, but you can say cast iron. Okay, so just make sure you make that difference. And the same with steel. You can't say steel because, again, steel is quite a generic term. There are loads of different kinds of steel. So at the minute, as you can see on the board, on the screen rather, you've got low carbon, medium carbon, and high carbon steel. You then do something later on when you alloy them to make all the other kinds of steel. So if you're going to mention steel, you've got to be specific on the different kind of steel as well. So your non-ferrous metals, so we talked about them before as being the ones that don't contain iron, and we have looked at their uses already and why they've got those uses. It's also worth pointing out the melting points of them as well, because that again is an important property that means they're suitable for certain things, because properties do change as you heat up materials. Okay, so things like copper have got a very, very high melting point, which is why it's perfect for things that will withstand quite a lot of heat, whether that is through electrical current or water. Whereas ones that got lower melting points will not be used as frequently or for certain jobs. I remember, as I said, and if you've had a look at the manufacturing processes video already, and you talk about how you change the properties of metals. If you heat them up, you change the properties of something that is quite brittle. If you start to heat it up, typically it will not be brittle anymore because you've changed the structure of the material on the inside, and that's why sometimes if you heat something up that was brittle, it can then become malleable because you heat it up and now you can start hit it in place. So and it may come up asking you about the melting temperatures or the melting points rather. If you don't get it bang on, normally it asks you like within the nearest 100, that sort of thing. So just make sure you're aware roughly of what their melting points are. So alloys. So an alloy can be either ferrous or non-ferrous, depending on what you've mixed it with, obviously. Now the whole point of alloying is it lets you create a different material that has better properties. Okay, so essentially there was a time before these existed where people were trying to make something and there wasn't a material suitable. I'm like, oh, what do we do? So okay, we've got these two different materials that have got similar properties that we want. Let's mix them together and see if we can make this new material. And that's essentially the theory behind how alloys came to be. All right. So the most common ones you've probably heard of like bronze and brass, and that's essentially it's copper and it's either tin or zinc. Again, you're not likely to be asked what percentage of zinc do you mix with brass, mix with copper to get brass, for example. But you may well need to know. It may well be say, okay, what is brass made up of? And it may say, okay, it's copper and zinc. Okay, duralium. And this is why I said it's important to make sure it's two or more metals, not just two. So you got copper, magnesium, manganese, and then aluminium. That gives you duralium, which is very, very, very strong. And then nitinol, and yes, I know there's a spelling mistake there. There should be an N there. Nitinol is, you will see that in the smart materials videos as well. That is the metal that essentially you can bend and deform, and then you can apply heat to it or sometimes electrical current, and it will snap back into place. There was a big trend in the 2000s where people had like glasses frames made from them. So then if you like sat on your glasses, you could heat them up and they would snap back into place. They're used in things like dental, like train tracks for dental work. Because over time, when it reacts to the body heat, it snaps those back into place. Same with if you've ever had like pins and things put in your arm, they can use that because it reacts to the body temperature. So it will slowly start to set the bone back in place as well. So alloying steel. So as we said, with steel, you've got iron, which on its own, pretty useless. Take iron, mix it with a certain amount of carbon, and you get low, medium, or high carbon steel. From that, you then can alloy it to get much more useful steels as well. So we're going through quite a lot of materials, or different kind of metals rather here, and you're not expected to be able to name every single metal in exam paper, because it just honestly is not very likely you're going to have to do that. Typically, as I said, questions tend to be, they give you an example of a product, they ask you to name a suitable material, and then say why it's suitable. That's normally the structure of how questions will go. If you don't know, the best thing to do is sort of have an educated guess and sort of have a bank of 3 or 4 materials that you always go to. For me, the one, if I never know, I normally have a throw out a stainless steel, because it's such a widely used material because it's got such good properties. So if in doubt, I'll throw a stainless steel out there. I might throw an aluminium out there if I don't know. If I know, then obviously I'll put the right one. But yeah, it's good to just have these. If in doubt, it's always a good one to chuck out because it's used so much. So yeah, you take stainless. So you take a steel. You would then have chromium, nickel, and manganese, and that basically will get you stainless steel, and that is used so much in your kitchen. Most people's sinks, excuse me, are probably made out of stainless steel, or your cutlery, or medical equipment like scalpels and all those sorts of things are stainless steel because it is so good. It's got such good wear resistance. It's incredibly clean. It's scratch resistant. Um, and actually, it's used a lot in kitchens because actually, for the most part, it looks quite nice because you don't have to finish it. High speed steel, so you alloy that with tungsten, chromium, and vanadium, and it's very hard, and it'll cut at when it's red hot, which means particularly in a workshop, if you say got like a drill bit or a CNC router, that sort of thing, if it because of friction it starts to get hot. If parts start to deform, so bend a little bit, it's not going to cut anymore. So that's why you have to have high speed steel, because it can withstand such a high temperature that doesn't matter how much you use it, it'll still work absolutely fine. Excuse me. Then you got tool and die steels. So these again are very hard, tough, good wear resistance, because you think most tools you've seen either in school, college, or even in industry if you go into manufacturing industry, that sort of thing. But obviously you don't want to be using a tool, or you can't use a tool that is softer than the material you're trying to cut, because you're not going to get anywhere. So that's why they're very, very hard, very tough, good wear resistance, so they can just withstand workshop use basically. And that's where you kind of get the idea of understanding um, like educated guesses if you don't know. So if a question might be, why is tool steel suitable for workshop equipment? And you know, okay, it's in a workshop. It's got to withstand general use. It needs to have good toughness, good hardness, those sort of things. Because you know, if not, it would be useless. Then you got high tensile steels, which are done with nickel, which are essentially used for car engine parts because it can withstand quite a lot of heat, and it's got good tensile strength. So you're talking like pistons and those sorts of things where it's getting heated up and it's being like pulled and pushed quite a lot. So it's got a very good strength in those sorts of circumstances.
So, realistically, with the exams, you're going to have to apply 2 or more topics together in question. So it might well be that there's a metals question, but then that'll be part of it, and the next part will ask you about metal processes, or it might ask you to compare a metal product to a wooden product. So you need to be able to apply that knowledge across 2 different topics. So first question, you should have seen this one before. So name a specific metal for the sink, 1 mark. Explain in detail why the metal you've named is suitable, and then use notes and diagrams to explain in detail how the sink has been formed. So a total of 15 marks. I'll give you a breakdown of the question. So the first one, name a specific metal for the sink. So that is 1 mark. So that's a simple response. Just state, you don't need any explanation, you just need to go with that. Part B is explain in detail why that metal you've named is suitable, 6 marks. So broken down, realistically, that's 3 points to explain the properties, because that's why it's asking you how is it suitable. You need to talk about the properties of that material. So 3 marks for 3 properties, and then another 3 marks to explain how that relates to the sink. So question C, which is 8 marks. So use notes and diagrams to explain in detail how the sink has been formed. Now, if it says use diagrams, you've got to use diagrams, otherwise you're not going to get the full marks. If you were to just do bullet points and explain it, you get some marks, but if it specifically says use diagrams, you've got to make sure that you use them. So 8 marks in total, so realistically that's 4 points, and then explain it as well gets you your 8 marks. So a point for bringing something up that's relevant, and a point for explaining it. It's worth noting as well, once you've already brought something up, you've got the mark for it, don't then repeat it again, because you're not going to get the same mark twice. They're not going to award you the mark for the same answer again. So what I'd like to do now, if possible, pause it, have a go answering it. You can use your notes and your textbook as well, but then in a second I'm going to put the answers on the screen, so please do pause it, have a chance to answer the questions. So name a specific metal of the zinc, things like stainless steel, aluminium, aluminium alloy, beryllium. Most commonly people probably said stainless steel. So B, explain it in detail why the metal you've answered is suitable. So if I say most people probably chose stainless steel, that's the one I would have gone for. So things like doesn't corrode when it's exposed to moisture or air, so it doesn't look untidy, it's malleable, so it's easy to form, it's ductile, so it can press into shape quite easily, it looks nice, it's hard, which means it's scratch resistant. If you're ever not sure, when it tells you or asks you why it's suitable, think about the product it's actually shown you and just try and have an educated guess. So if it's, for example, a sink, you know that it will have to be corrosion resistant. You know that, okay, in a sink there's going to be water, there's going to be bleach, it needs to be able to withstand that, it needs to withstand scratching. So you can sort of reverse engineer an answer based on what it's given you. And then C, use notes and diagrams to explain in detail how the sink has been formed. So that will have been done with blanking. So there is a diagram on the right hand side to explain blanking. Now in the exam paper they're not going to expect a perfect, well drawn thing as long as your diagram is clear. So what the best thing to do with diagram is draw your diagram out and you can have bullet points next to it just explaining it. So basically your stainless steel sheet will be unrolled from stock form and straightened out. You will then have the sheet will be punched into blanks with a hydraulic press. So the blanks are transferred to a press where they're then clamped and the press pushes the sheets into shape. So slowly with pressure it will form the shape. There may be several presses to achieve the shape, so they may have to go down a couple of times to make it go deeper, or if they're going to have punching in it, if they're going to have plugs or taps or anything like that, so to stop it from overflowing. So just remember, if it says use diagrams to explain your answer, you've got to make sure you're using diagrams, otherwise you can't physically get more than half marks. So the next one, match the following fabrication methods to the applications in the table below: soldering, MIG welding, arc welding. So in this case it's quite simple, this is multiple choice, you can only use each method once. So again, pause the video, have a go at answering it. You can use your textbook and your notes, but I'm going to put the answers on in a second, so please just pause it so you get a chance to answer it yourself. Okay, so joining aluminium to aluminium, that would be MIG welding. Copper to copper for jewellery, soldering, because it requires less heat. And joining mild steel to mild steel will be arc welding or MIG welding. So if you put MIG welding, you won't be able to put it for aluminium. So I mean, if you put MIG or arc, you'd be right for either one, but remember that you can only use each method once. Next question, so name a specific metal for the bench and then explain in detail why the metal you have named in part A is suitable. So remember, as I said before we went through these questions, you're going to have to mix or join more than one theory together. So far all the questions have asked you the metal, which is fine, which just covers the metals topic, but then they've asked you to talk about the processes that go with it as well. So we really are combining two topics together. So the first question, so name a specific metal for the bench, that's 1 mark, dead simple. That is just name a suitable material and no explanation needed. So the next one, explain in detail why the metal you named is suitable. So that is 6 marks. So like before, 3 points and then an explanation for your second point gets you 6 marks in total. So you can talk about the properties of the material and or the manufacturing processes as well, because it's not specified exactly, it will be up to you, it's fine. So specific material for the bench, probably again most people have said stainless steel. You could add mild steel or aluminium. And then examples of why the metal has been named is suitable. So if you said stainless steel, it's very hard material, so it's not going to scratch, it can't be vandalized easily, doesn't corrode, withstand weather, so it's not going to rust and fall apart, and so it looks nice as well, so it's attractive. Next question, so name 3 ferrous and 3 non-ferrous metals by completing the table below, and then it asks you to go over more detail. Next question, so for one of the metals you've named in part A, give a suitable use, and then give 2 reasons why this metal is suitable. So, your ferrous metals, you could have had mild steel, stainless steel, high carbon steel, cast iron or carbon steel, and then your non-ferrous metals, aluminium, copper or silver. So with a question like this, because it's asking to use your answer from part A into part B, if you don't get part A right, you then can't get the rest of the marks for the rest of the question. So it's important you get the next question right. So if you think something like silver, then obviously it can be something like jewelry. And then why is that suitable? Because it can be soldered to make rings, it can be polished so it's attractive and it looks nice. So name a suitable metal for the toaster body, 1 mark, and then explain why this metal is suitable for the toaster body, 6 marks. So remember what we talked about before with the breakdown of questions. So 1 mark is quite simple in explanation. 6 marks, okay, so that's 3 marks for 3 parts for being right, and then an extra 3 marks for your explanation. So typically you would get a separate insert in your exam paper that would have you coloured pictures of the product, and it'll tell you what it is, and it'll ask you to talk about certain parts. So if this one specifically, it's looking at the metal toaster body. So again, you probably could have said stainless steel. That's always a really good one if it's most things. And then aluminium alloy. So stainless steel, good aesthetic look, so it looks nice in most modern kitchens. It's malleable, so it's really easy to press and form into shape. Stainless steel doesn't corrode, so it gives good hygiene. Yeah, so again, most people, stainless steel is coming up quite a lot, but it's a very, very good product used quite a lot in industry. So match the finishes listed below to the materials and applications given: galvanizing, dip coating, chrome plating, acrylic based paint. So again, multiple choice question. Have a look through your notes, try and answer them, and then pause it and we'll go through the answers. So mild steel would be galvanizing, bathroom taps would be chrome plating, car bumper would be acrylic based paint, and steel pliers would be dip coating. So that is the end of the revision for metals. I will put up a video of last year, first year metals as well for you to go over it if you're not sure as well. But the whole point with the second year revision is making sure you can just take the information you've got and try and practice and applying it to exam questions. If you've got any questions, please drop me an email and I'll do my best to make a video tutorial for you, or just email you a reply. Thank you.